Oh, sorry. I forgot to turn on my mic. Assalamu alaikum. How are you?
Welcome, Salam. I'm all right actually.
All right. Thank you for coming in such short notice. Okay. All right. So we were studying. We were actually at the very end. You could say, or you could say, even it's the beginning of redox reactions, right? So,
Mm,
so we completed this chapter. Just look at this question. This shouldn't be difficult if you have understood these things. Okay. All right. Um. Okay. So these are like practical investigations. Why is it taking so long? Okay. All right. So now let us start. Before that, let me check if there is anything from my book that you should know here. Um, One thing is that I have previously told you that reactions could be of two types based on do they occur in both directions or do they occur in only one direction? Okay. So one thing you could say that is irreversible reactions. What does that mean? That means you will only see a forward reaction and you won't see a backwards reaction. Okay. Only a forward reaction will happen and backward reaction won't be seen. What I mean by that is calcium carbonate here is getting decomposed to form calcium oxide and carbon dioxide. Okay. But you won't see that calcium oxide and carbon dioxide together is forming calcium carbonate. Okay. So that is what irreversible reaction means. Okay. That is, you will only see the forward reaction. This direction is the forward reaction. This is the forward reaction.
mm.
So this is our forward reaction. Okay. And in the opposite direction, this is our backward reaction. Okay. Backward reaction. Now, this particular concept is really important, especially to understand La Chatelier's principle. The backward reaction, the forward reaction, and the backward reaction. Okay. I hope it's understandable. Now, if I ask you one question, I've previously discussed it a lot of times. Why do you think there is no like presence of backward reaction in this case? Like, why isn't calcium oxide and carbon dioxide forming calcium carbonate here?
Um, I don't think I've ever seen a gas and a solid willingly go back
Right.
to a solid.
Yes. So, to put it into like simpler words, say for instance, you are doing it in a open chamber. You're doing performing the reaction in open chamber. So these are calcium carbonates, and you have applied heat. Okay, you have applied heat. Okay, so now that means you will have a solid portion of it, which is calcium oxide. Okay, but the carbon dioxide, which is gaseous, it will just flow away. Okay, so if it is not in the system now, is there any possibility that calcium oxide itself will turn into calcium carbonate? The answer
No.
is right. That is why. If you were working with a closed chamber, then it might have been possible to get a backward reaction. Okay. All right. Reversible reactions. Reversible reactions are those which go in the forward direction as well and the backward direction as well. So as you can see, ethanol and ethanoic acid forms what's the name what's going to say, I mean something ethanoid, ethyl ethanoid, yes, ethyl ethanoid. Okay, see, ethanoid will be formed and water will be formed. Okay, and in effect, after it has formed these two things, they will perform the reverse reaction and form these two as well. Okay, so this occurs as a, what can I say, reversible reaction. Okay, and the main basic reaction behind this, like if I show you, whenever you will study about alcohols, there are like some, what can I say, some specific composite ions which can be identified which can be used to identify a particular organic compound. So if you see OH, that means it is a, tell me what, it is an alcohol. Okay, alcohol. Okay,
Ooh, yummy. I'm kidding.
and if you see a COOH composite ion, actually, I mean, a composite ion might not be the correct translation to this. You could say that, I mean, anything. Uh, I mean, if I draw, say, for instance, a structure, you would understand. Okay, one second. So let's say this is CH3COH. Okay, CH3 and COH. So one of the hands, carbon has valency of 4. Okay, so 3 of the hands are occupied with, I mean, anything possible. Okay, most likely hydrogen or carbon. Okay, but one hand has to be occupied with COOH. That would make it a fatty acid. Okay, what is a fatty acid? Fatty acid. All right. And if I would have given here, say for instance, not COOH, I have given here OH, that is alcohol. So it will become an alcohol. Okay. All right. Understand my point? So this is how organic chemistry
Understand.
works. We will study about them in detail later. So here an alcohol and fatty acid is reacting with each other to form an ester. What is an ester? We will study about that later. And I mean water. Okay. So to easily understand this thing, you could maybe memorize it like this. Say for instance, here you will take an H or hydrogen from here and OH from here, and then make a water or give a water first, and then the leftover will be made to ester, an ester. Okay. See here we would have only CH3COH. Okay. Sorry, CH3COO after hydrogen is released, and here we will have C2H5. Okay, so they will together form CH3CO C2H5. Is it a little difficult or is it understandable?
No.
All right. All right. So main thing is this is a reversible reaction. Okay, right. Next up, so this is also a reversible reaction, like whenever we are reacting with hydrogen and iodine to form hydrogen iodide. Okay. Okay. Now, as we saw in your book, exothermic, endothermic reactions. Okay. Exothermic reactions. Okay. Think about it. Exo means to go outside, right? Like, I mean, I'm just trying to make it a little simpler. So, exo. Don't we say like exit or something like that? So, this is like going outside. Okay. Something like that. I mean, I'm just trying to simplify it. And you will be able to understand. So, in case of exothermic reactions, heat will be released to the environment. Heat will be released to the environment. What is the environment? Anything in our surroundings is called the environment, right? So in case of a reaction, anything outside the reaction is called the environment, right? I'm just like
Yes.
simpler ideas. Okay. So when heat evolves, okay, evolving, it's a very important term. When heat evolves at the time of producing the products from reactants, whenever the product is produced and then heat is evolving or heat is being released in the environment, the reaction is called exothermic reaction. Reaction is called exothermic reaction. For example, 1 mole nitrogen and 3 moles. Why is it called 1 mole nitrogen? Let's see how much you remember. Why are we calling it 1 mole nitrogen?
Uh, where?
Why are we saying that 1 mole nitrogen is reacting with 3 moles of hydrogen?
Uh, okay, so nitrogen is formula for that. It would be S times.
You are going in the wrong direction. I did not say that.
I'm going
Say
terrible.
for instance,
Um,
if I give you another. Another equation, very easy equation. Okay, Na plus plus Cl minus, and that forms NaCl. So how many moles of sodium ion chloride and sodium chloride is present here?
One.
Right. 1 mole of sodium plus ion. Why am I saying that? Because from the equation, we can see that one is ahead of Na plus and one is ahead of Cl minus as well. Okay. So this was particularly the idea gotten from the equations or reactions, idea of moles, right? We might
Yes.
add, say for instance, 2.25 moles and 5 moles. Okay. But this is the basic amount of moles that should be needed for the perfect balance. Okay, which we can get the idea from a balanced equation, right? That is what we studied. Understand my point?
Yes.
So here you can see it's a balanced equation. Okay, so now what is in front of N2 or nitrogen gas?
One.
That means there is 1 mole of nitrogen gas. And what can you see in front of hydrogen gas?
Three.
That means 3 moles of hydrogen gases are present. Okay, and this forms 2 moles of ammonia. Okay, all right. And
All right.
plus 92 kilojoule, it means that 92 kilojoules of heat will be released. Okay, you can do it with I mean, what can I say, different presentation. That would be N2 gaseous plus 3H2 gaseous, and then Fe here works as a catalyst. Okay, Fe is the catalyst here. What is a catalyst? Catalyst, I mean, helps to, I mean, what can I say? Helps to perform the reaction, okay, or maybe to increase the speed of the reaction. Okay, it just helps. And what should be the ideal air pressure? It will be 200 to 250 atmospheric pressure, and the ideal temperature should be 450 degrees Celsius to 550 degrees Celsius. Now, don't be confused like, why they have said like a temperature here and they are saying that 92 kilojoule of heat is being released. See, temperature and heat are totally two different things. You might have studied that as well. Okay. Temperature here is the like temperature of the system. At what temperature should you perform the reaction? Okay. And heat is being released, or maybe it could be like grasped in some cases in the system. Okay. Or outside of the system. Understand the difference between heat and temperature? Say for
Yes.
instance, if I give another example, say for instance, if you are boiling hot water, say for instance, now you are touching the, what can I say, the container of the boiled water, then you will feel heat. Okay, you will feel heat, and the measurement of that heat would be like 200 degrees Celsius. Okay, understand my point? So there is a difference between them. Again, say you are feeling feverish. So if someone touches your forehead, he or she might feel that it's like you are releasing heat from your body. But what will be your temperature? Around 101 degrees Celsius or 102 degrees Celsius. Okay. All right. So enough said about these things, but these are important things. Okay, because we will start when we will study La Chatelier's principle. You will see. Okay. So you can write it like delta H equals to negative 92 kilojoule. Now, why did I write negative? Why did I write negative? Can you tell me?
Um, the balance.
To balance,
Um,
what is delta H? What do you think delta H is?
heat.
Not heat, the difference of heat. Okay, the difference of it.
So delta
Okay.
means difference.
Yes, obviously delta means difference. So
Okay.
delta H is equals to heat of forward reaction, you could say. Forward reaction minus heat of back. Uh, I don't know if it's going to be difficult or not. Okay, once again, let's not write it like that. Okay, not forward, forward or forward direction, backward direction. Okay, let me tell you like this. Okay, say for instance, what bonds do you see? Okay, so whenever you create bonds, a particular sort of energy is being, what can I say, uh, inserted, okay, to create bonds. Okay, and whenever you are breaking the bonds, energy will be released. Okay, so in the left side you see N2. So N2's bond is somewhat like this, N triple bond, and we will do various maths regarding this, so don't be afraid, just I'm trying to make you understand. N triple bond N. Okay, and then you can see H single bond H, and you see three of the bonds here. Now this particular thing will have a particular heat, is that correct?
Yes.
So this will be equal to, say for instance, x kilojoule. X kilojoule. Okay, this is for this portion. Okay, and in case of the right side, let me erase some of the things, otherwise in case of the right side we have NH3, right? So let us see the bonds for NH3. So nitrogen, one hydrogen, two hydrogen, three hydrogen. So we can see three NH bonds, right? How is it three? See, this is one, this is two, and this is three. Okay.
Yes.
Okay, good. So three NH bonds, and also there are two of it. Okay, two of it. All right. So this implies, say for instance, y kilojoules. Okay. Now your delta H will equal to x minus y kilojoule. X minus y kilojoule. Understand my point?
E X what?
X minus y. The
Oh,
one,
X minus 1.
the amount of heat on the left side, okay, amount of heat in the bonds of the left side minus the amount of heat in the bonds of the right side. Okay, that is what delta H implies. Okay, all right.
Can I just write this down?
Yes, obviously, take your time.
Yeah.
You will need it. But it was in your book. I mean, wasn't it in our syllabus? But I don't understand. You don't complete the whole books, right?
We used to do that, but now because we're in grade 11,
Yes.
we are gonna go through the whole textbook
That's good. That's better.
in order. Yeah.
Are these books like provided by government? Like government has designed some education curriculum, and based on that, writers write it, or are these
Pretty
like
much.
random books? Okay, so that's better. It's better because if it's like random books by random writers, and if you have to figure out what to read from where, it becomes really difficult. At least at school, the level of school and college. Okay, because when you will go to university, there is no particular syllabus actually. The more you want to learn, the more you are allowed to learn. But in that way, it's difficult to do great at some point because you don't get like enough time for studying everything. Okay, and to get good grades, it's important that you put emphasis, proper emphasis on all the subjects. Okay. So that is why it's very important to do all the classes, and also to follow the teachers lectures, because most of the teachers give questions from what they have, I mean, shown lectures on, given lectures on. Let me know when you're done.
Yeah, we're done.
So now plus 92 kilojoule heat was released in the environment. Okay, so that means the heat of 2NH3 is greater than the heat of N2 plus 3H2. I hope it's easy to understand. It's not that difficult. Heat of 2NH3, that is after producing, the amount of heat is greater than in case of when the bond was forming, right? Understand that?
Yes.
Okay. So now we did consider this to be y kilojoule, and we considered this to be x kilojoule, right? So now tell me, if y is greater than x, then what will we get in case of x minus y? You will get it a negative, right?
Yes.
That is what I written down. What I have written down here. Okay,
Whoa.
difficult, a little difficult. Okay, let us try a match then. Maybe it should
Oh,
be
okay.
all right. Okay, have you taken notes of these?
Yes.
But get a math. See, okay, 1 second. Math of endothermic, exothermic reactions. Let's say. I think exercise should be better. Exercise. Okay, and these are not maths. Uh, okay. Let me see my book then. It was the next chapter. Test things. See, okay. Delta H is equals to total internal energy of the products minus total internal energy of the reaction. All right. Did I say it? 1 second. Yes. Total internal energy of the products minus total internal energy of the reaction. So delta H. So the total internal energy of reactants is greater than the total internal energy of products. Therefore, the value. Okay. 1 second. The thing I wrote down. Okay, so no, this won't be x minus y. Okay, this would be y minus x. Just a second. Oh, I just so y minus x. Okay, all right. Okay, everything's correct. Everything's correct. So just what you have to do, the thing is just getting reversed. That is, you will have to first calculate the internal energy of the products and then uh, minus it. I mean to the internal energy of the reactants. Okay. So again,
Hmm.
right, delta is equals to, it's better, yes. English definitions are better now. Delta is equals to total internal energy of products minus total internal energy of reactants. Okay. So everything is correct. I mean, whatever we have just discussed, but the thing will just get reversed. Okay. All right. Can you hear me?
Yes, I can.
Okay. All right. Just uh, correct it. Okay. All right. Okay. So now, in case of the total energy of products is greater, then delta H will be positive. In case that total energy of reactants is what can I say, greater, the delta H will be negative. Okay. All right. Now notice here is a very important thing written here. In exothermic reactions, the total internal energy of reactants is greater than the total internal energy of the products. That is why delta H becomes negative. Okay. And that is also the reason why heat is being evolved. Say for instance, we started with 150 kilojoules in case of reactant. Now it makes all the more sense. In case of reactants, okay. Now after all the procedure is done, now in case of the products, we get say for example 130 kilojoule. Now, as we know that energy cannot be vanished, right? Energy stays in the system or energy stays in the environment, and the total energy in the world is I mean, what can I say, definitive, right? So the other 20 kilojoule will be released as heat. This is the amount which we are calling heat evolved. Heat evolved. Okay. All right. Understand my point?
Yes.
Okay, good. All right. And in case of endothermic reactions, as you can presume that this will be minus and the heat will be absorbed. Okay. Say for instance, in case of say we are starting with 100 kilojoule. Okay. And 120 kilojoule for say products. Okay. So minus 20 kilojoule, and this minus 20 kilojoule will represent that heat will be absorbed. Okay. Heat absorbed. And another thing to be cautious of is that whenever you are writing with plus or minus, and whenever you are writing it with delta H, the signs will change. Like in case of heat evolved or exothermic reactions, delta H will be negative. Here delta H will be negative, delta H negative. And in case of endothermic reactions, where heat is being absorbed, delta H will be positive. Let me just zoom in a little, which will make it easier for you to like take notes of this. Okay. Why am I saying these things of delta H and like heat evolving, heat absorbing too many times? Because you are bound to be confused about this, because I mean each and every student gets confused at the very beginning. Okay. Even you saw that I messed up the formula a little while ago.
Mm.
All right. So tell me when you're done.
Denzo.
All right, so let's see if we can get a math. I think there was a math. Okay, so you don't have to memorize this chart. Whenever the question setter is giving you any question, he will give you the chart. Okay, so based on this chart, we have to, I mean, what can I say? They calculate if an reaction is endothermic or exothermic, or there is no particular
I
change
have a
in
question.
temperature. Yes, go ahead.
Sorry about interrupting, but on the chart, why are some of the bonds have one line and why are some have three?
Okay, very good question. So one line means, okay. So for instance, nitrogen. Okay. So for instance, let me give you an example with nitrogen. Okay. The nitrogen is 1s2, 2s2, 2p3. Is that correct?
Yes.
So whenever nitrogen, say for instance, it tries to bond a single bond. Okay. It's a very high thought question actually, but let me try to make you understand as easy as possible. So 2s2, 2p3 for the other one as well. Okay. Now 1s2 and 2s2 is filled up, but this 2p has to be 6, right? So what they
Yeah.
do is they try, these 1 and 1 will get joined with each other. Okay. This p1 and p1 will get joined, for instance. That gives us 1p2. Okay. And another p1, we write actually px1. Okay. And py1 and py1 will get joined again, and pz1 and pz1 will get joined. So after all these things done, you can see that the p is now filled up. Okay. Now, after forming the bond or the three bonds of between two nitrogens, we are getting 2p6. Is that correct?
Yes.
That is why nitrogen is forming three bonds. This is a very easy explanation. You will have to study hybridization of orbitals to understand it even more. Because whenever you see a single line, that is called a sigma bond. What did I say? A sigma bond. Okay. Single line means sigma bond. And in case anything more than a single bond will be regarded as pi bonds. Okay. So in case of say triple bonds, the first. Okay, can you hear me?
Yes.
I don't know what just happened. Um, okay, whatever. So where was I? So yeah, sigma bonds and pi bonds.
Yeah.
Yes. So whenever you say single line, it will be sigma bond. Okay. And whenever you see like more than one, first one will be regarded as sigma bond. So sigma, and other two or other one would be pi bonds. Okay. These are pi bonds. So it's not that easy as I said, like uh, in case of like say one line, it forms say for instance a px1 and another px1 and then another py1 and py1. It does not occur like that easily, but uh, I mean as I could say is that um, to fulfill the or fill the orbitals, the number of bonds needed are created between the compounds. Sorry, I mean the elements. Okay, that is the simplest thing I could say. And whenever you study
Okay.
about the sigma bonds, pi bonds, hybridization of orbitals, which is obviously in your curriculum of 11th and 12th, okay, you will go through them one by one, so you will understand about them. Okay, all right.
Okay.
All right, and yes, that's about it. And based on that, we would see that how the what can I say, the bonds of particular compounds form, and based on that, we can calculate the bond energy as well. Okay, so let's try. But before that, I think I might as well need to give another link. It's 36 minutes. Okay, let me give another link.